MySQL is one of the most popular relational databases out there. And if you're wondering whether it's the right choice for you, you're in the right place. So let's kick things off with a bit of history. MySQL was created in 1995. Fast forward to 2010, it gets acquired by Oracle, and even though Oracle does still own it, MySQL is still open source and continues to be a go-to for many developers around the world. As a matter of fact, according to the Stack Overflow 2024 Developer Survey, MySQL is the second most popular database in the world. Now, why is MySQL so popular? Let's break it down. MySQL is fast, particularly in read-heavy operations. This is partly due to its efficient use of indexing and its ability to handle large datasets with ease. For example, the InnoDB storage engine, which is the default for MySQL, uses clustered indexes that store rows in a sorted order, making retrieval operations incredibly fast. Additionally, MySQL's query cache can actually store the result of a select query, allowing future requests for the same query to be served from the cache, reducing the load on a database server. Next, scalability and flexibility. MySQL is highly scalable, which means it can handle everything from small personal projects to large-scale projects, which is why high-traffic websites like Uber, Airbnb, Netflix, and Amazon actually use it. It also supports horizontal scaling through techniques like sharding, where data is split across multiple databases, and vertical scaling as well. One of the reasons MySQL is trusted in production environments is actually because of its support for ACID properties, and particularly when using the InnoDB storage engine. Why is this such a big deal? Well, this ensures that transactions are processed reliably and that the database remains in a consistent state even in case of a crash or power failure. For example, InnoDB's use of the redo log helps in recovering from unexpected shutdowns, preserving data integrity. MySQL also offers robust replication options, including master-slave replication. This is where changes on the master database are replicated to one or more slave databases. This setup is crucial for high availability and load balancing. Additionally, MySQL's support for GTID, aka Global Transaction Identifiers, simplifies the process of failover and recovery in a replication setup, making it easier to manage and maintain high availability. Now, what I think is the most important feature with every database is security, which is a top priority in MySQL, which is also why it features things like SL encryption for client-server communication, support for roles that simplify privilege management, and robust authentication plugins. MySQL also allows for fine-grained access control. This means you have the ability to specify permissions at the database, table, or even at the column level, giving you the ability to enforce security policies as tight as possible. The grass is not always greener on the other side, so let's also talk about the cons when it comes to MySQL. Number one, limited compliance. MySQL's implementation of SQL isn't fully compliant with the SQL standard, particularly when compared to databases like Postgres. For example, MySQL lacks support for advanced features like common table expressions and window functions in versions before 8.0. And this can actually be a huge limitation for you if you need to work with complex queries that require these features. Latency can also be an issue. In traditional master-slave replication setups, there can be a latency between the master and slave databases. This means that the slave database might not always have the most up-to-date data, which will obviously be a drawback for real-time applications where consistency is obviously critical. Unfortunately, you also have limited storage engine features. While MySQL's pluggable storage engine architecture is flexible, not all engines support the full range of features. For instance, MyISAM, which is faster for ready-heavy operations, doesn't support foreign keys or transactions, which will make it less suitable for applications requiring strict data integrity. Now, this would not be a proper MySQL video if I don't talk about the licensing. The dual licensing model of MySQL with both GPL and commercial licenses can lead to confusion, especially for companies needing to navigate the terms and conditions carefully to avoid potential legal issues. Let's say your project requires embedding MySQL in a closed source application, or if you need enterprise level features and support. Oracle offers commercial licenses as well, but you would obviously need to actually pay for this, unfortunately. So to sum things up, MySQL is a robust, versatile, and high-performing database that stood the test of time. It's perfect for a wide range of applications, but like any technology, it's important to be aware of its limitations as well so you can make the best informed decision for yourself. Anyway, I hope y'all liked the video. Let me know your thoughts in the comment section, and I'll see y'all next time.